Hello everybody, this is Mr. Fry with another video. This would actually be part 2 for using the specific heat formula. Last video I took a look at how to solve for Q, which was the amount of heat needed in order to make some temperature change in a certain amount of a substance. This time I'll use that same equation to solve for mass, which would be the M, C, which is the specific heat of a substance, and for delta T, or the change in temperature. I have one practice problem in this video for each of those three variables, so I'll go ahead and start the first one with you. Keep in mind the clip art I put into these videos is there just to kind of provide some kind of visual component. So this is not necessarily the object that the question is talking about, but we can go with it for now. It says a metal with a specific heat of 0.780 joules per gram per degree Celsius requires 45 joules of heat to raise the temperature by 2 degrees. So what is the mass of the metal? In order to solve this problem, you would want to go ahead and start with the specific heat formula. Q equals M times C times delta T. And the substitutions that you would make in this problem, you're pretty much going to get everything from the question itself. So the mass is what you're solving for. The Q is the amount of heat needed, so that was the 45 joules part, so you're going to have 45 as the substitution here for Q. We're going to leave M as M, and we're going to substitute in that specific heat of 0.780 joules per gram per degree Celsius in for the C, and then we're going to have the change in temperature from the problem as well. And it says that this amount of heat is needed to raise the temperature by 2 degrees. So that is telling you the change in temperature. In the previous video, you noticed we have to do the final minus the initial temperature whenever we're solving for Q. But here this problem is literally telling you what delta T's value is. So you don't have to do any subtraction here. You just sub in the values we just mentioned. So we got 45 equals M times 0.780 times 2. And from this point forward, it's standard basic linear algebra, and you're going to combine like terms on the right. You're going to multiply, and then you're going to, at that point, since you're doing M times 1.56, you want to take and do the opposite operation of that and divide both sides of the equation by 1.56. Using a calculator, M equals, you do 45 divided by 1.56, you should get 28.8 grams. As the mass here. Now keep in mind this is not a mistake. This is not supposed to be kilograms like many of the other formulas we've learned in my class. Since the specific heat of a substance is measured in joules per gram per degree Celsius, then the mass is going to come out in grams. That is a final answer. So here is the second example problem, and this one is for solving for the specific heat of a certain substance. For this question, it says a substance requires 50.0 joules of heat to raise its temperature by 6 degrees Celsius. It says if the mass of the substance is 5 grams, then what is the specific heat? Just like all of these problems, you should start with the formula. It is your key to the answer. And we need to take a look around here and figure out what we're solving for in there, which you will remember is specific heat. That is the C. So C is going to remain C. Everything else, Q, M, and delta T, we have to get from the problem or use our brain. Sometimes it's not immediately available in that problem, but usually it is. So it says how much heat is required. That's the Q. It gives you the mass. That's the grams. And it gives you the amount the temperature is going to change. So yet again, we just plug in that 6 degrees in for the delta T. So the substitutions for this problem look like this. And then I just started undoing, basically, the multiplication you see there on the right. So you've got 5 times C times 6. So you could go ahead and start dividing by those numbers and getting C by itself. I went ahead and divided both sides of the equation by 5. That turned it into 25 equals C times 6. I need to undo that times 6 by dividing both sides by 6. And you should, in your calculator, keeping in mind these are going to cancel, so you're going to have C by itself over here, because 6 divided by 6 is 1, and 1 times C is C, so that just drops down to C. So you're doing in your calculator 25 divided by 6. The final answer on this problem should come out as 1.67 joules per gram per degree Celsius. Okay, here we have the final example problem. It's a metal with a specific heat of 0.70 joules per gram per degree Celsius, and a mass of 8.00 grams, and it says it absorbs 48 joules of heat. And it wants to know in this one what the temperature change of the metal is going to be. So for this problem, we're actually solving for the delta T, the change in temperature. So we should be able to find values for Q, M, and C in the problem, which is exactly what we see. We have the Q as 48 joules. That's the amount of heat. We have mass. That's always going to be in grams in these kind of problems, unless they're trying to trick you so that you have to do a conversion from kilograms to grams. But here, we do not need to do that. It's already in grams. And we have the specific heat as 0.7. And we'll put that in here. And delta T will remain the variable. Okay. On the right side of the equation, you need to combine like terms. You need to go ahead and multiply 8 times 0.7. That gets me 5.6. Bring everything else down around it. And then you need to undo delta T times 5.6. In order to undo a times, you divide both sides of the equation to get that delta T by itself. Here you would divide both sides by 5.6. So delta T is equal to, go ahead and make sure you realize this is going to go completely away. This is going to cancel. Delta T equals 48 divided by 5.6. Use a calculator, and you should come out with 8.57 degrees Celsius. That is the amount that the temperature is going to change for this metal when it absorbs this amount of heat. Okay, guys, I hope you found the video helpful. Please like or subscribe, and I promise I'll be getting a new microphone soon. Thank you for watching.